right, Algebra 2 people. Hope everything is going okay. We are almost at the end of the chapter, and so we're starting to kind of wrap up some of the concepts so that they kind of all go together. So this first little part is sort of a repeat of what we talked about in 4.6, but if f of x has x minus c as a factor, well, what does that mean? That means that f of c equals 0. It means that c itself is a 0 of f of x. And another word for being a 0 is it's an x-intercept. And it also means that it is a root or a solution. So we have all these meanings that go along with that. And remember that if you have a let's say if x minus c squared is a factor, so you have a double factor, then how do I want to write this? Then the graph bounces on the x-axis at x equals c. Okay, so that's how you can tell if you have a double root from the graph. All right, so what we're going to do is we're going to be given an equation, and using everything we know about degrees and lead coefficients and even odd behavior and the roots, we can give ourselves a pretty decent sketch. So the first thing you always want to kind of determine is what degree are you working with. So notice I have an x here, and then I have an x squared. So this is going to be a third degree. That means it's an odd function. Remember, that means the branches go in opposite directions. My lead coefficient is 1/6, which is positive. So I know that in general, my graph will have this shape to it. So you'll have the two turnarounds. Your final end behavior is going positive direction. So that we can get just from looking at the degree and the lead coefficient. The second thing we notice is our x-intercepts. Those are going to be x equals a -3 and at x equals 2. Now since it's x minus 2 squared, and again I'm getting these by setting each factor equal to 0, what I like to do is write bounce on this one because it's going to bounce on the axis. Then let's see, the last thing that I would like you guys to be able to find is the y-intercept, because that gives us a little bit of a perspective on the graph. We find the y-intercept by letting x equal 0. So I'm going to take my equation 1/6. We have 0 plus 3 and 0 minus 2 squared. So that is going to equal 1/6 times 3 times -2 squared is 4. And that is going to give us a y-intercept of 2. So let's start to put some of this on our graph. So I have my x-intercept at -3. You always want to label the axis with any critical point that you're putting on there. Don't just leave it as a dot and then have us counting tick marks. So here's 2. And I know that I'm also going to cross the y-axis at 2. So here's your y-axis, x-axis. And then using what we had determined about the basic shape of the graph, we know we're going to come up, we're going to cross the y-axis here, we're going to bounce at 2, and then take off. And that would be graphing a cubic function without actually plotting a lot of points or having to do any table of values. It's pretty powerful just to be able to use the degree, the lead coefficient, and a couple characteristics from the graph. But now that you did a graph from an equation, we're going to go the other direction and we're going to come up with the equation given the graph. And you've actually already done this. You did this with the quadratics because we're going to do it in what would be called the intercept form. So you have a x minus root 1, x minus root 2. That's what we did with the quadratics. Now we're going to have a cubic, so we can go 1 degree further, but the process is going to be the same. So when I look at this graph, I see that my roots are going to be -2 and a +1. and I'm going to have a 3. And then there's also a point, a particular x, y that we're going to need to be able to solve for a, and that's going to be 2, -1. So you didn't have that on your notes, but I added that point there because you need that point to solve for a. So now we're going to kind of do this step by step. Let's plug in our roots. So y equals a, we have x minus a -2, x minus 1, and x minus 3. So that's plugging in our roots. Then we're going to take our x and our y, and we're going to plug these in. So I have -1. There's the a we want to solve for. And wherever I see an x, I'm going to plug in a 2. So I have 2 minus 1 and 2 minus 3. And then let's work this out. So this is -1 equals a times 4 times 1 times a -1. So -1 equals a times a -4. And solving for a, notice we get a positive 1/4. So again, you always want to kind of make sure your answers make sense. And notice in this graph that since our graph is going up, you would expect that lead coefficient to be positive. It kind of helps because negatives do tend to be the one thing people mess up on. So let's put it all back together. So we now have y equals 1/4, x plus 2, x minus 1, x minus 3. There is your final equation given the graph. And this last bit, estimate the coordinates of the max and the minimum value. Well, this is just a, sort of a, you can kind of come up with your own. We're going to approximate that. So let's say we have a maximum at -0.8, 2, and we will use the minimum, which I've already kind of labeled, at 2, -1. So again, it's just an approximation. Usually when you're sketching, we don't necessarily know where they are, and that's okay. We have the main critical points. Okay?